If you work with 3D elements in After Effects, you have likely hit this exact wall. You apply a depth of field effect to your passes, the timeline stutters, your memory maxes out, and the system crashes to an error screen. You can achieve cinematic, photorealistic depth of field without melting your hardware. The goal is to build a project file that plays back smoothly and never lags. To pull this off, we use the 2REST Big File framework to organize our composition data. Think of it like cooking for a large group. If you need to serve 10 people fried rice, you don't cook 10 separate tiny batches from scratch. You cook one massive batch in a wok and then simply change the serving bowls. We are going to apply that exact logic to our 3D render passes. Mastering this data structure saves your hardware from crashing and shaves hours off your total render time. By organizing the math behind the pixels, you remove the unnecessary strain from your computer. Step 1 happens before we apply a single effect. Go into your After Effects project settings, switch the color depth to 32-bit floating point, and interpret your imported Z-depth EXR file as linear. A Z-depth pass acts as a precise digital ruler. In this grayscale image, the exact brightness of every single pixel tells the software the physical distance of that point from the camera lens. In an 8-bit color space, which holds only 256 shades, gradual distances break down into harsh, blocky stares. Switching to 32-bit floating point provides over 4 billion values per channel, filling gaps with microdata points to create a perfectly continuous gradient. Starting with 32-bit clean data ensures your CPU doesn't waste cycles trying to calculate focus through broken, stair-stepped information. Now we hit a rule that goes directly against standard editing logic. When you look closely at your raw Z-depth pass, the edges of your objects will look heavily pixelated. You must not apply anti-aliasing to smooth them out. Smoothing averages the bright foreground and dark background into a gray pixel. Because gray dictates middle distance, you build a physical bridge floating in midair. The plugin fails to calculate focus across this false distance, wrapping your focused subject in an ugly, glowing halo. To prevent this, your Z-depth pass must have hard, jagged, aliased edges. Every single pixel must hold one uncompromised distance value, sitting firmly in either the foreground or the background. To fix those jagged edges on the final video, we use the double resolution technique. Render 3D passes at 4K resolution, apply your depth of field plugin, and scale it down to 1080p. Scaling the image down acts as natural supersampling. The edges smooth out on your screen, but because the blur math was calculated at a high resolution before the scale down, the depth data remains intact. With clean data and proper resolution, we follow the normal route methodology. Apply a physically accurate blur plugin, like Frischluft Lens Care or Fast Bokeh, directly to your 4K Z-depth layer. Grab the focal point picker and click around different objects in your scene. The focus will shift organically from foreground to background with zero edge tearing. When a client asks for 3 different focus variations of the same shot, artists often duplicate the entire heavy 4K composition 3 times. This instantly turns a manageable project into a crashing mess. Instead of copying the heavy composition, we use a check layout paired with After Effects Essential Properties panel to apply the weak rule in state. Open your main timeline, the base layout. Find the focal point and blur radius inside your depth plugin and drag those specific values up into the Essential Graphics panel. This exposes them as master properties. Drop that base layout into a new check layout timeline. Because of the weak rule, you can override the focal point on this nested layer without altering the original master. You can duplicate this layer 50 times, changing the focus on each instance, while After Effects only references one lightweight master composition. Mastering this state-based workflow keeps the project file tiny and agile, even when delivering dozens of complex client revisions. Now that the layout is approved, we execute the main cache pause. We intentionally halt the heavy 3D calculations to let the workstation rest. Take that finished check layout and render it out as a high-quality video file. Bring that video back in and attach it directly to the composition as a proxy. Go to Preferences, clear your media cache, and route that cache to a dedicated SSD. Keep it completely separate from your system drive to prevent data bottlenecks. Offloading these 3D calculations to a proxy removes software lag by freeing up your system's resources for creative tasks. Here is the result. The macro shot racks focus across the complex geometry, the transitions are fluid, and the edges are clean. Despite the complex depth calculations, the final project file is only a few megabytes on the hard drive, and the CPU load stays near zero during real-time playback. Apply this pipeline to your next heavy 3D composite. Use 32-bit linear data, keep your depth edges jagged, render at double resolution, and use proxies to give your machine a break. Optimize